What's up, guys? This is Kurt from Polymath Sports. For those who don't know me, I got my PhD in 2017 and started working as a data scientist at that time, and still work as a data scientist today. Um, so today I'm going to walk through some of our algorithms that we have to offer and just break down what each one does and what you can expect to get out of these algorithms. And if you have any questions at all, feel free to contact us. So first, starting with probably the most simple, but not by any means the worst algorithms, ridge and lasso regression. These are classic linear regression algorithms that basically can handle a large amount of features and also can handle when your features are correlated, which is sometimes a common problem in modeling. Like if you have too many features that are predicting the same thing or they have the same relationship to the outcome, it can kind of muddy the model. And ridge and lasso have this kind of penalty on the algorithm that will prevent too many variables from essentially, sort of, you can think of it as sort of fighting with one another to predict the outcome. And so this is a really good model if you have, sort of straightforward relationships between your predictors and your outcome, and that there's a kind of linear relationship. A good example would be, predicting points scored based on free throw percentage or based on average points per game. Those have probably a fairly linear relationship, and so those would be good variables to put in a ridge or lasso regression model. Now, the accuracy on these can be really good if you find the right set of variables to use. It's often a little bit of an art, and maybe takes a little time to tinker with the algorithms and which variables you're putting in to see which ones will give you the best results. But a lot of great results have been achieved through just ridge and lasso regression. And I personally use a ridge regression model in my own modeling for sports. So that's ridge and lasso regression. The next algorithm is decision tree, and this can handle nonlinear relationships. And whereas in ridge and lasso, you might have to, what I mean by that is, you may have complex nonlinear relationships with your variables to the outcome. And in ridge and lasso, you might have to explicitly code that in. And currently, it takes a lot more modeling and a lot more manual effort to do that with a linear regression. But a decision tree will kind of figure out these nonlinear relationships for you, and we'll just model them. And the accuracy on this can be good. However, overall, I would say if you're going to use a decision tree, I would recommend using a random forest, which is basically just a bunch of decision trees that put together. And we'll get to that in just a second. But I think a decision tree is really good to use on our site if you want to see the nature of your relationships. So as we're getting started, we have still a little bit to fine-tune on our model reporting, but in the very near future, you will have the option, if it's not already there today, to see the output of your decision tree, so you can actually trace to see which of your variables are contributing to the outcome. Like, for example, if you want to know if, what's a better predictor of home team points, and you want to know whether it's the free throw percentage, the average points per game, the average three-pointers per game, etc. You can basically test a bunch of these variables out in these models and see which ones are more associated with the predicting the right outcome, and which ones are less associated with it. So this would be good to help you with your kind of feature selection process. and can be good as a standalone model too. Now, support vector machines, I would say these are a little bit more complex to explain. The mathematics on these is quite complex, and the accuracy is medium. I put medium just because I've seen cases where support vector machines do extremely well. I've also seen cases where they don't do extremely well. And this is just one truth about data science. There's not one algorithm that is going to fit your data set perfectly every single time. You probably want to spend some time experimenting with each of them, see which one gives you the best results given your predictors and given the sport that you're on. I've personally found some algorithms work better with our NBA data compared to the NFL data, and I will leave that up to you to independently discover which algorithms will give you the best results for your sport that you're interested in. But I would say support vector machines can be not hit or miss, but there's kind of can be a range of accuracy in sports analytics from what I've personally seen. I'd say when to use, when you have a little bit of time to wait, although on our site, the training of these models is extremely fast. So I would not worry about time being an issue. But when you want to just try another algorithm, I definitely recommend you throw this into the mix and see if, the same variables, in these other algorithms are giving you either worse or better performance. Next is the last algorithm in the basic tier. And this is one of a really high octane model and has won a lot of competitions in data science. It's called the random forest model. And the accuracy on this can be very good at times. Basically what it is it's a collection of a bunch of mini decision trees that are all decorrelated from one another. And the reason they're decorrelated is when you decorrelate a bunch and you kind of aggregate them all at the end, you get this really robust, accurate model. So imagine like each decision tree gets a vote on whether, your home team's going to win or not. That's one particular model. But if you have 100 or 500 decision trees, you kind of get the majority vote of those 500 trees. And the end result tends to be much more accurate than just relying on one single decision tree. It's a very good algorithm. I've had a lot of success with this in this context and a lot of other contexts in data science, and is just an excellent model to use. So when you have a lot of predictors and you want to know, obviously you want to get good predictions, accurate predictions, but you also want to know something about the feature importance, this would be a good model to use. And again, if we don't have this in already at the time of you viewing this video, we will have it soon. We're in the model report. You'll actually see a breakdown of what are the top 10, top 20 features that are contributing to your predictions. And that'll be informative for you as you're trying to figure out what are the best variables to include in your model. Now, that's all the basic tier algorithms, and that honestly is a good set of algorithms to get started with. We wanted to give everybody a really good starting place, whether they're just choosing a free, one prediction per day model versus the basic membership versus the premium membership. However, for the premium users, this is where things get really nice for you from a modeling standpoint. We get into algorithms that are pretty much state-of-the-art and have shown excellent performance across many domains and have kind of really established themselves as just the best algorithms that are out there right now in data science. The first one is gradient boosting. And it's similar to random forest in that you have a bunch of these mini trees that make up the final model. But essentially, in a gradient boosting algorithm, it kind of has this iterative training process where it'll build the first tree, it'll make some predictions, and maybe it'll find some errors during training. And then on the next iteration, it'll go back and it'll correct those errors. So it'll try to predict on what it got wrong. And so it kind of just iteratively gets more accurate as you go along in the training process. And the end result of gradient boosting is really incredible. It's won tons of competitions in Kaggle and other areas of data science, and is just, again, a really solid algorithm to use. Here the accuracy is high, and this is really great when you have many predictors and complex relationships among those predictors. And I will just tell you from my own experience in sports analytics, you can get decent results with something like a ridge lasso regression or even a random forest. But I've found personally the gradient boosting algorithm has given me the best results, at least in some sports. So that's why we charge a little bit more for it, is that it gives you a boost in accuracy, and it just gives you basically what you're paying for. So this is another great algorithm. And again, like a random forest, you'll be able to break down the feature importance of your variables. So you want to know the top 10 or 20 variables that are contributing to the outcome prediction, the accuracy of it. You'll be able to obtain that information in the model reports. Finally, neural network, probably one of the coolest algorithms out there. It's basically this really robust model that is like a linear ridge regression on steroids, where basically you kind of get these linear combinations of features, and just in the first stage it might connect to a set of nodes, and then those nodes connect to another set of nodes in the middle, and each of those nodes has, sort of individual weights associated with each node in the next layer. And then eventually you kind of boil it down to a single prediction, and the final output layer will be your predicted outcome. And it is modeled after how the human brain works. It's not an exact 100% model of how the brain actually works, but it is kind of modeled after the idea of this neuron firing. Once it obtains a certain level of activation threshold, it'll fire, and that might set off, an association to another set of neurons. And it's roughly loosely based on how human brains work. It is extremely accurate. It can handle lots and lots of variables, and you kind of have this ability to sort of just throw a lot of variables in, and if the training process is long enough, it can kind of figure out the optimal set of variables to use and sort of pare down your features. So it's extremely powerful. Again, that's why it's in the premium tier, and you have access to it. The accuracy is very high on neural networks, and just a really great algorithm. Gradient boosting and neural networks together is pretty much cream of the crop in data science. So that covers it. I hope this was informative for you. There's definitely a lot more to modeling than just picking an algorithm and maybe picking a few features. But we will have lots of education resources available for you to help you on your modeling. It is definitely a journey, and it's something that you'll get better at over time. So I definitely look forward to hearing your feedback on these. Feel free to shoot us a message. Tell us what's working, what didn't work for any particular sport. We're interested to hear what you guys come up with as well.